Hello, algebra students. Mr. Lawrence here with a little quest review for you. And the first part is solving equations. Remember, we have to determine if it's a linear, quadratic, or cubic. If it's linear, we're going to work to get x alone. If it's quadratic, we're going to get the equation equal to 0, and then we're going to look to factor it. So let's check out this first one. It looks like a linear equation to me, so I'm going to listen to Saddam, undo my subtraction and addition before I undo my division and multiplication. So I'm going to take away 4. I bet you Kevin can tell you why we're taking away 4, because the 4 is positive. This negative belongs over here, right? So my equation transforms into x over 3, which will equal to 6, negative x over 3. And then now I'm going to have to multiply both sides by 3, but actually I'm going to multiply by negative 3. Why am I going to do that? Because it's going to take care of two problems for me at once. The 3's will cancel, but then so will the negatives. And I'll be left with a plain old x on the left-hand side. The right-hand side will equal negative 18. Now, if I wanted to test to make sure I did it right, I could take this negative 18 and plug it back in for x. So my equation would be 4 minus negative 18 over 3 minus a negative is plus a positive. Following the order of operations, I need to do division. So this is really the same as 4 plus 18 divided by 3, which is 6. And 4 plus 6 is 10. So you see my solution works. All right, on the second problem here, it looks like it's a quadratic. How do I know? Because the exponent is 2, the highest exponent. All right, so I'm going to get it equal to 0. And I'll do so by subtracting 35 from both sides. Remember, when I do that, I'm not going to write that negative 35 under the 2x or under the x squared. I'm afraid I'll make some banapples combining unlike terms. So x squared plus 2x minus 35 on the left-hand side. The right-hand side is 0. And now I'm ready to factor. I need two factors of 35 that subtract to get positive 2. Well, sounds like a 7 minus 5 to me. So I'm going to rewrite this as x squared plus 7x minus 5x minus 35 equals 0. I'm going to do some grouping now. And as Zach Ingram says, capture the negative. Need a plus in between there. And now I'm ready to do a little GCF. And looks like there's an x. I'm going to factor out a GCF of an x plus an L of x plus 7 in the quantity. Here, my GCF is going to be a negative 5. And I'll be left with an x plus 7. That's good because they match. Now I factor out a quantity of x plus 7. And from this group, only x is left. From this one, only a negative 5 is left. So I factored completely. Now I solve. X plus 7 equals 0, or x minus 5 equals 0. And so x is going to equal negative 7, or x is going to equal 5. There are my two solutions. Now, just to show the point, hold on one second. Oh, good. Remember, my equation is x squared plus 2x minus 35. If I put negative 7 in, or if I put positive 5 in, I should get 0 for both equations. And just in the interest of time, I'm going to do it on a calculator. So my graph will come up here. And, oops, hold on a second. There we go. I'm not sure what that smarting thing is doing there. Let me get rid of that. So we're going to have negative 7, and that needs to be squared, plus 2 times negative 7. And then what is it? Plus minus 35 at the end. Minus 35. And look at that, I got 0. Okay? I can hit second enter, and the old problem comes up. And then where I see a negative 7, I'm going to delete the negative. And over type of 5. And I'll do that again. Delete the negative, put a positive 5 in. And so now you see I have 5 squared plus 2 times 5 minus 35. And the calculator knows the order of operations and generates a 0. Of course, you can check yourself. All right, let's get on with absolute value. Absolute value, the definition. Hopefully you all know by now. We've stressed it very well. By the way, my 8th period students, I've been so proud of you, the way you've come back from break, and I'm really hoping that you do well on tomorrow's quiz. Um, I've always known how intelligent you were, um, and now you're really starting to show it. And I'm having a little technical difficulty here. Hold on, let me pause the video till I get this figured out. Okay, looks like I got my technical difficulty figured out. So let's see here. The definition we said was the absolute or the distance from zero on a number line. It's actually the distance from some kind of center. And some of the problems, like say um, this one here, um, we're talking distance from zero, but on other ones it's actually a distance from some center. Okay. Um, anyway, so the absolute value of 5. How far is 5 from 0? Well, it's 5 spaces. The absolute value of 5 is 5. Absolute value of negative 7. How far is negative 7 from 0? Well, it's positive 7. So its absolute value of negative 7 is 7. All right, now to do a problem like this, the equals need to be done like ors. So I'm going to write down x equals 6, or x is going to equal negative 6. I have to get x alone, but in this case, x is already alone. And so there's my two answers, right? Now this one, some of you will get fooled by. I need to know what numbers are negative 2 units, a distance of negative 2. Remember, this is the distance number, right? This is the distance. Negative 2 units from 0. Well, there are no such numbers. This has no solution. No solution. All right. Now, jumping down here, when I have the absolute value of 3x minus 2 is less than, this is an and, right? Less than and it's less than 10. So I'm going to write 3x minus 2 is less than 10, and 3x minus 2 is greater than negative 10. And I'll solve both parts for x. Okay, 3x is less than 12. Dividing by 3 will tell me that x is less than 4. And I'll come over here and I'll add 2. And I'll get 3x is greater than negative 8. Dividing by 3, I'm going to get x is greater than negative 2 and 2/3. Now remember, whenever it's an inequality, I'm going to graph it on a number line. So if I got a number line here, and get some arrowheads on him, and I'll show the number 4, which is over here. It'll have an open point, and the number negative 2 and 2/3, it'll have an open point. And the ands go together, right? So I need the numbers between them, so the shading will look like that. Okay, now when I go to do the next one, it's an or, isn't it? So I'm going to do 5 minus 2x is greater than or equal to 25, or 5 minus 2x is less than or equal to negative 25. Going to subtract 5. I'll get negative 2x is greater than or equal to 20. Don't lose that negative right there. Divide by negative 2. Whoop, 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 whoop. There should be some warning signs going on. When I multiply or divide by a negative in an inequality, my inequality changes direction. So I'm going to get x is less than or equal to negative 10. Over here, I'm going to subtract 5. Oh, so I forgot my or. Subtract 5, and I'm going to get negative 2x. Don't lose the negative, which is going to be less than or equal to negative 30. Divide by negative 2. Whoop, 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 whoop. There's that alarm again. Make sure you don't forget that when you multiply or divide by a negative, the inequality changes directions. And I'm going to get 15 there. All right. So I'm going to get 15. Going to get negative 10. closed point on both of them. Ors typically go away from each other, right? You know, let your thumbs out, pointing away. And I'll just test it. I want the numbers greater than 15. Well, they'd be over here, wouldn't they? I want the numbers less than or equal to negative 10. Well, the less than ones would be there. Okay, last two problems. What's my center here? My center is going to be 4, right? Because that'll make it 0. Whatever makes the inside 0 is my center. So, what number is less than or equal to negative 1 units? This is my distance number, remember? So I'm traveling a distance of negative 1. That should bug the heck out of you. You can't travel less than negative 1. This has no solution. Now be careful. Don't make a mistake. I know Derek's paying attention to this. Here my center is going to be negative 1/6. Okay, if you're wondering how I got that, I got 6x plus 1 equals 0, and I solved for x. I'll let you do that on your own, but you will get negative 1/6. And this is my distance number. So I need to know what numbers on the number line are more than a distance of negative 3 away from negative 1/6. Well, the smallest distance I could be would be 0, wouldn't it? If I was sitting at negative 1/6. So that means all real numbers are going to work. All real numbers. There you go. All right, that's your review video for the quiz. If you take it seriously, if you prepare, if you've been doing your homework, I know you're going to do very well on it. All right, that's it for today. Mr. Lawrence signing off. Have a good night, everybody.